Hi, I think that the easiest way to solve this problem is to draw a tree diagram of the particular situation. Not sure if you're used to that or not, but a tree diagram just shows all the possible scenarios of the events that are occurring. When you first start out, you pick your first student. That student could either like pepperoni, cheese, or have no preference. So we can just label that pepperoni, cheese, or no preference, and then the second student picked has the same possibilities, pepperoni, cheese, or no preference. And you do the same thing a third time. And you'd complete this entire tree, and it would have all the possible scenarios that could happen. I've already done that here. I have a tree complete for this scenario. Each situation here has the probability of that event happening. For instance, for the first person, there are 7 people that like pepperoni, and so and there are a total of 16 students. So the probability that a person would be picked that liked pepperoni is 7 out of 16. And you do the same thing for the cheese is 5 out of 16, and no preference is 4 out of 16. And then you do the same thing on the second step. Only in the second step, if the first person picked um, liked pepperoni, there would only be 6 left, and there's only 15 students left because you've already picked one. So the probability of picking a person that liked pepperoni of the second person would be 6 out of 15, and for the third time would be 4 out of 14. So anyway, you complete this entire chart here, and the nice thing about it is it's going to have your answers for all your questions. If you're looking for the scenario where all 3 students preferred pepperoni, it's right here on the top, pepperoni, pepperoni, pepperoni. So the probability of that happening is 1 out of 16. For the second question, the first student preferred pepperoni and the other 2 preferred cheese. Well, that's right here, pepperoni, cheese, cheese. So the probability of that happening is 1 out of 24. I neglected to say that to calculate these probabilities, what you do is you take each one of these and multiply them, right? I've got that listed on here. So for instance, pepperoni, pepperoni, pepperoni is 7/16 times 6/15 times 5/14, and it turns out to be that's 1 out of 16. For question 3, the first person liked pepperoni and the other 2 preferred cheese. That was 1 out of 24. For the question C, first person didn't have a preference, so NPC. NPC is right down here. Probability of that happening is 1 out of 24. None of the students preferred cheese. Well, that's a little trickier because you've got a bunch of different possibilities here. So none of the people preferred cheese. This one, this one. Let's see. The second whole block is out because this was cheese. This one, and then all of these are out because this has cheese. And then this guy, this guy, this guy, and this guy. And so what you do is you just add these all up. When you do that, I actually already did that on the side here. Turns out to add up to 33 out of 112. So that's the answer to D. Now, question E is easy because it's really just the complement of question D. So if none of the people preferred cheese, then the opposite or complement to that is that at least one person did prefer cheese. So this is just going to be 1 minus 33 out of 112, which turns out to be 79 out of 112. Hopefully that was helpful to you.